All right, we're going to talk about secants, tangents, and chords and some of the relationships that we find when these three types of segments and lines intersect. First of all, we have a picture of two chords that intersect. Of course, a chord is a segment whose endpoints lie on the circle. So when two chords intersect, they intercept some arcs, like so, and there's an angle that's formed in the middle. The way that we find the value of x is we add the arcs and divide by 2. So if I find the way that I find the value of x is 40 plus 50 divided by 2. And on this section, I'm just going to show you examples because this is the way that the problems work. I'm not going to write down the theorems, but you add that divide by 2, which means x is equal to 45. Two chords that intersect. Here we go. Two chords intersect. They cut two arcs. How do I find that angle? I add 70 plus 80 and divide by 2. 70 plus 80 is 150. Divided by 2 is 75. That's what you do when you have two chords that intersect. What if I have two secants that intersect? Now these two secants are going to intersect and form an angle outside of the circle. But when two secants intersect, they form an angle and they also intercept two arcs. So do not add the two arcs together and divide by 2. We subtract the arcs and divide by 2. 100 minus 50 is 50 divided by 2 is 25. The measure of angle x is 25. So I should already put that up there. Just a reminder. Tangent intersects a circle once. A secant it's a line that intersects a circle twice. The diameter goes through the middle of a circle. It is a chord. Goes to the center. A chord has its endpoints on a circle. Of course, a secant contains a chord. That is a chord right there. Those are the words that we're using. So we've had two chords that intersect. We've had two secants that intersect. Now we have a secant and a tangent. Now, just like the secant that intersected a moment ago, when you had two secants that intersected, they intersect and form an angle outside the circle. Same way with a secant and a tangent, and there are two arcs. You do it the exact same way. So you subtract 120 minus 50 and divide by 2. 120 minus 50 is 70 divided by 2 is 35. So the measure of angle x is 35. So we've had three different pictures. We've had two chords. With two chords, you add the arcs and divide by 2. Then we've had two secants, and we've had a secant and a tangent. And on both of those, you subtract the arcs and divide by 2. The next picture, of course, would be two tangents. So once again, the angle is outside the circle. You do this the exact same way as you do two secants. And as a secant, you do a secant and a tangent. We're given that arc is 200. The rest of the way around the circle then is going to be 360 minus 200, which means this arc is 160. So I have the two arcs, 200. Subtract 160 and divide by 2, and you get the measure of angle x, which is 20. Here's an example where instead of looking for the angle, you're looking for the arc, but you do the same thing. You add the two arcs. The arcs are 20 and x, and you add those together and divide by 2. When you add 20 plus x together and divide by 2, you have to get the angle. So multiply both sides by 2. 20 plus x equals 80. Subtract 20, and x is 60. Now you always need to check and see if it works, which it does. If you add the two arcs, 20 plus 60, and divide by 2, you get the angle, which is 40. All right, back to the same pictures. We had two chords, we had two secants, we had a secant and a tangent, we had two tangents. Back to the same picture, except now instead of being interested in the angles, we are interested in the segments, because when two chords intersect, they divide. Each chord is divided into two segments. And so in this picture, I have one chord is divided into A, B, and one chord is divided into C, D. And here is what is true every single time the two chords intersect in a circle. A times B equals C times D. that relationship is always true. You multiply the two segments that are formed by one chord together, and that's equal to the two segments formed by the other chord. For example, I want to solve this problem. 6 times x equals 4 times 8, so 6x equals 32, and divide by 6. So x is 32 over 6, or 16 over 3. Two chords, that's what we just did. Of course, the next picture is going to be two secants. And so here's the way that it works with two secants. You take the entire segment length of the secant, a plus b, and you multiply that times the outside part, which is a, and that equals the entire length of the other one, which is c plus d, times the outside part, which is c. So it's the entire length, a plus b, times the outside part, a, equals the entire length, c plus d, times the outside part, c. This is the way that it works when you have two secants that intersect. For example, oops, don't want to do that. For example, one more time. There we go. The entire segment, the top segment, is 12 plus x, and you want to multiply that times the outside part, which is 12, and that equals the entire segment on the bottom, which is 14 plus 10, and you want to multiply that by the outside part, which is 14. So let's do this. That is 12 times 12 is 144 plus 12x equals, that's 24 times 14, which is what? 24 times 14. There you go. There's two secants. Now we have a secant and a tangent. Now you really do this the exact same way, except with the tangent you only have one segment instead of two. But you still, with the secant, you go the whole segment, a plus b, times the outside part, which is a, equals, and you really do the same thing, the whole segment, which is c, times the outside part, which is c, so you just square it. So it's the secant is the whole segment, a plus b, times the outside part, a, and that equals the tangent segment squared. For example, the whole segment in this case is 4 plus 8 times the outside part, which is 4, is equal to the tangent segment squared. So that is, let's see, 4 plus 8 is 12 times 4 is 48, equals x squared. So x is the square root of 48, or 4 square roots of 3. One last picture, of course. We did two chords, we did two secants, we did a secant and a tangent, and then there are two tangents, but we already really know what this is because we already learned that from a point outside a circle, if two tangents meet at a point outside a circle, that they are equal. So A equals B. If we wanted to do it, really you could follow the exact same process as the other problems. You would go A squared equals B squared because they're both tangents, but of course if A squared equals B squared, then A equals B.